Hello everyone, welcome to this video where we'll explore an essential topic in PySpark, the difference between select and filter in PySpark. Both select and filter are powerful data frame transformation methods, but they serve entirely different purposes. While select helps you focus on specific columns, filter allows you to narrow down rows based on conditions. In this video, we'll dive deep into how these methods work, their use cases, and when to use one over the other. Let's get started and break down these two core concepts in PySpark. Introduction. In PySpark, select and filter are essential data frame transformation methods, each serving a distinct purpose. The select method is used to choose specific columns from a data frame, helping you narrow down the data to just the fields you need for analysis or processing. On the other hand, the filter method is used to apply conditions and extract rows that satisfy specific criteria, enabling you to focus on a subset of the data. Together, these methods allow for precise control over both the structure and content of a data frame, making them invaluable for data manipulation in PySpark. 1. Select. The select method in PySpark is a powerful transformation function used to extract specific columns from a data frame. It allows you to reshape the structure of your data by narrowing it down to only the columns you need for analysis or further processing. Functionally, select works similarly to the SQL select statement, enabling you to specify one or more columns you wish to retain in the resulting data frame. Unlike some other transformations, select does not affect the rows of the data frame, it only determines which columns to include. This makes it ideal for focusing on relevant fields without altering the underlying data. When you apply select, it creates and returns a new data frame containing only the specified columns, leaving the original data frame unchanged. This non-destructive behavior ensures flexibility, allowing you to experiment with different transformations while preserving the original structure. The select method is commonly used for selecting a subset of columns for further analysis, projecting specific fields when preparing data for output or visualization, creating simpler data frames with only the essential fields for downstream operations. Its simplicity and versatility makes select one of the most frequently used methods in PySpark for column level transformations. Practical example. This example demonstrates how to use the select method in PySpark to extract specific columns from a data frame. The step-by-step process highlights how this transformation method allows you to reshape your data while preserving the original data frame. So step 1, initialize Spark session. The Spark session is created using the Spark session.builder method. The application name is set as select example and getOrCreate initializes the session. This Spark session acts as the entry point for creating and managing data frames in PySpark. Step 2, create a sample data frame. A list of tuples is defined as sample data, where each tuple represents a record with fields like ID, name, department, and salary. The created data frame method converts this data into a PySpark data frame with the specified column name serving as the schema. For example, the first record one, Alice, HR 5000 represents an employee named Alice in the HR department with a salary of 5000. This structured data frame is displayed later for comparison after applying transformations. Step 3, select specific columns. The select method is applied to the original data frame to create a new data frame df underscore selected containing only the name and salary columns. This transformation filters the columns, keeping only those explicitly mentioned while leaving the row data unchanged. Step 4, show the selected data. The df underscore selected.show method displays the resulting data frame, which includes only the name and salary columns. This demonstrates the effectiveness of the select method in narrowing down the dataset to the required fields. For instance, Alice's name and salary Alice 5000 are shown while columns like ID and department are excluded. Step 5, print the schema for reference. To better understand the changes made by the select operation, the schema of the original data frame is printed using df.print schema. This shows all the columns ID, name, department, and salary with their respective data types, emphasizing that the select operation only affects the new data frame and does not modify the original schema. Step 6, show the original data frame. The original data frame is displayed using df.show to confirm that it remains unchanged after the select operation. This highlights the non-destructive nature of the transformation, as PySpark always creates a new data frame when transformations are applied. This example showcases the versatility of the select method, making it a fundamental tool for column-level transformations in PySpark workflows. 2. Filter. The filter method in PySpark is a powerful transformation function used to filter rows in a data frame based on specified conditions. It enables you to focus on subsets of the data that meet certain criteria, effectively narrowing down the dataset for analysis or further processing. Functionally, filter works similarly to the SQL where clause, allowing you to apply logical conditions to rows. These conditions can include comparisons, ranges, string matching, or combinations of multiple criteria. Unlike select, which operates on columns, filter operates on rows and determines which rows are included in the resulting data frame. When you apply filter, it creates a new data frame that includes only the rows satisfying the specified condition. The original data frame remains unchanged, demonstrating the non-destructive nature of PySpark transformations. This makes filter particularly useful for tasks like data cleansing, focusing on relevant subsets of data, or preparing data for further transformations. For example, you can filter rows where a numerical column exceeds a certain value, a string column matches a specific pattern, or null values are excluded. The method is highly flexible, allowing you to apply single or multiple conditions using logical operators like and, or, and not. The filter method is a fundamental tool in PySpark workflows, providing precise control over the rows in a data frame and enabling efficient data analysis and processing. Practical example. This example illustrates how to use the filter method in PySpark to filter rows in a data frame based on a specified condition. The filter method allows you to extract subsets of data by applying logical conditions to the rows, focusing only on the relevant data for analysis or processing. Let's break this down step by step. This is step 1, initialize Spark session. The example begins with the initialization of a Spark session, the entry point for all PySpark operations. The session is named filter example, and the getOrCreate method ensures that the session is initialized. This setup provides the environment for creating and manipulating data frames in PySpark. Step 2, create a sample data frame. A list of tuples is defined where each tuple represents a record with the following fields: ID, unique identifier for the record; name, the employee's name; department, the department where the employee works; salary, the employee's salary. The createDataFrame method converts this data into a structured PySpark data frame with column names ID, name, department, and salary. This data frame serves as the input for the filtering operation. Step 3, filter rows where salary 6000. The filter method is applied to the data frame to extract rows where the salary column is greater than 6000. The condition df salary 6000 specifies the filtering logic, ensuring only rows meeting this criteria included in the resulting data frame df underscore filtered. For instance, the row for Charlie with the salary of 7000 is included. The row for David with a salary of 6,500 is included. Rows for Alice and Bob with salaries below or equal to 6,000 are excluded. Step 4, show the filter data frame. The df underscore filter dot show method is called to display the filter data frame. The output includes only the rows where the condition salary 6,000 is satisfied. This step verifies the effectiveness of the filtering operation. Step 5, print schema for reference. The schema of the original data frame is printed using df.printSchema to highlight that the structure of the data frame remains unchanged during the filtering process. The schema shows all columns ID, name, department, and salary with their respective data types. Step 6, show the original data frame. The df.show method is used to display the original data frame for comparison. This step confirms that the filter method does not modify the original data frame but instead creates a new one, demonstrating the non-destructive nature of PySpark transformations. This example highlights the flexibility and power of the filter method in PySpark, making it a critical tool for row-level transformations in distributed data processing workflows. Key differences The key differences between select and filter in PySpark lie in their purpose, effect, and use cases. Both are essential methods for data frame transformations, but they serve distinct roles in data manipulation. Let's break down the differences. Purpose. Okay. The primary purpose of select is to choose specific columns from a data frame. It operates on the structure of the data frame, focusing on reducing the number of columns to only those relevant for analysis or output. On the other hand, filter is designed to apply conditions to rows, extracting only those rows that meet the specified criteria. While select focuses on columns, filter focuses on rows, effect on rows. Select does not alter the rows in the data frame, it simply projects the specified columns, leaving the row data intact. In contrast, filter directly impacts the rows by including only those that satisfy the filtering condition. For example, using select name, salary keeps all rows, but only the name and salary columns. Using filter df salary 6,000 removes rows where salary is less than or equal to 6,000. Effect on columns. The select reduces the number of columns in the data frame by selecting only the specified ones, while leaving the original data frame unchanged. On the other hand, filter does not affect the number or structure of columns, it operates solely on the rows. This makes select useful for column level transformations and filter ideal for row level filtering. SQL equivalent. In SQL terminology, select is equivalent to the select clause, which specifies which columns to include in the query result. Filter mirrors the functionality of the where clause, which applies conditions to filter rows in a query. This parallel makes these methods intuitive for users familiar with SQL, as they can directly map SQL concepts to PySpark transformations. Use cases. Select is best suited for situations where you need to project specific columns, such as preparing data for visualization, output, or further processing. For example, if your data frame contains multiple columns, but your analysis only requires name and salary, you can use select to simplify the dataset. Filter, on the other hand, is ideal for narrowing down datasets based on conditions. For instance, if you need to analyze employees with salaries above a certain threshold, you can use filter to extract only the relevant rows. Summary. Select modifies the structure by reducing columns, leaving rows unchanged. Filter narrows down the data by including only rows that meet specified conditions. They complement each other by providing control over both column select and rows filter enabling precise data manipulation in PySpark workflows. Understanding these differences allows you to effectively use select and filter together or independently, depending on whether your task involves column projection, row filtering, or both. And that's it for our discussion on the difference between select and filter in PySpark. To summarize, select is all about choosing specific columns, while filter focuses on extracting rows based on conditions. Together, they form the building blocks of efficient data manipulation in PySpark. If you found this video helpful, don't forget to like, share, and subscribe for more PySpark tutorials and data engineering tips. Thank you for watching and see you in the next video.